All right, let's get right into it. We hear the term artificial intelligence thrown around all of the time, but what is it really? How does a computer go from just following a list of commands to, well, seemingly understanding things? We're going to pull back the curtain and see how AI grew up, from solving simple puzzles to doing things that honestly feel a little bit like magic.
And really, it all comes back to this one huge question. I mean, think about it. Some things are easy. You can write a recipe, you can write a list of instructions. But how do you write the rules for recognizing your best friend's face or figuring out if a sentence is a joke? You can't. And that's the challenge that forced AI to become something truly special.
So, where does this whole journey begin? Well, it starts with the most fundamental building block of AI, just searching for an answer. The simple act of finding a solution to a problem. It might sound basic, but trust me, it's way more powerful than you think. Let's just imagine for a second that you're standing at the entrance to a giant maze. You know where you are, you know where you need to get to, the exit, and you know your options. You can go left, right, or straight. That's it. That is the core idea of a search problem in AI. So to put some official terms on it, your initial state is just where you're starting in the maze. The actions are your possible moves, left, right, forward. And the goal state? Well, that's the exit. The whole job for the AI is to figure out the exact sequence of moves to get from the start to the finish line. So how does it actually do it? At its core, it's pretty simple. The AI starts at the beginning and looks at every possible first step it could take. It keeps a list of all the paths it started but hasn't finished exploring yet. Then it just works its way through that list, methodically, one step at a time, until, bam, it finds the path that leads to the goal. And this isn't just a toy problem. This is happening in your pocket every single day. When you ask Google Maps for the fastest way to get somewhere, it's not just looking at a map. It's solving a gigantic, real-time search problem with thousands of possible paths, factoring in traffic, road closures. It's just a much, much bigger maze. Okay, so let's level up. Finding a path through a maze is one thing. But what if the maze is actively trying to beat you? This is where AI has to learn how to be strategic. We're talking about games, right? Tic-tac-toe, chess, you name it. All of a sudden, you're not just looking for an exit, you have an opponent. And that opponent is trying to ruin your day. Every move you make, they get to make a counter move. So to deal with this, AIs use a clever strategy called minimax. It's basically a super pessimistic approach to playing a game. The AI's goal is to maximize its chances of winning, but it does this by assuming that its opponent is a genius who will always make the perfect move to minimize the AI score. It's like asking, okay, if I do this, what's the absolute worst thing they can do to me in response? And this table here, this is a perfect snapshot of that thought process. The AI looks ahead. Okay, if I make move A, they can win. That's bad, forget that. What about move C? Oh, they can win there too, also bad. But wait, what about move B? The absolute best they can do is force a tie. It's not a win, but it's the best possible outcome when you assume your opponent is perfect, so it picks move B. Now, so far, we've been programming the AI with all the rules of the maze, the rules of tic-tac-toe. But this is where the real revolution begins. This is the moment we stopped telling the computer the rules and just started showing it examples. This slide just nails the difference. The old way to build, say, a spam filter was to write a million little rules by hand. If the email has $3, it's spam. If it has the word Viagra, it's spam. But the new way, machine learning, is totally different. You just give the computer thousands of emails that you've already labeled as spam or not spam, and you tell it, you figure out what spam looks like. In this whole approach, it has a name. Supervised learning. And it's called supervised because we're basically giving the AI a giant answer key to study from. We give it the inputs, like an email, and we also give it the correct output, the spam label. And the AI's entire job is to learn the connection between the two. So how does it actually learn from that data? Well, one of the most intuitive ways is an algorithm called k-nearest neighbors. Just picture a big chart with a bunch of dots. The blue dots are days it rained, and the orange dots are days it didn't. Now, a new dot appears for today, but we don't know what it is yet. The AI just looks at, say, its 5 closest neighbors. If most of those neighbors are blue, it's going to predict rain. It's literally learning by association. And you might be wondering, okay, that sounds cute, but how well does it actually work? Well, get this. One project trained a model to spot counterfeit banknotes. By just learning from the data from thousands of real and fake bills, it got to nearly 99% accuracy. It was spotting tiny patterns that no human would ever even notice. And that brings us to the really cutting-edge stuff. We're going to see how these very same ideas of learning from examples have been scaled up to create the mind-blowing AI systems we see today, the ones that can look at the world and actually talk about it. The inspiration for all this modern AI, it's you, it's me, it's the human brain. For decades, scientists looked at this incredible network of neurons that we have for processing information and thought, hey, could we build a math version of that? And the result is the artificial neural network. It's basically a system made up of layers of tiny computational units, kind of like digital neurons. And when you stack enough of these layers together, they become incredibly good at finding really subtle, really complex patterns in messy, real-world data, like pictures, sounds, and language. I mean, think about it. How would you write a list of rules to identify someone's sloppy handwriting? What makes it two a two? It's almost impossible to define. But you can show a neural network thousands of examples of handwritten numbers, and it will just learn. It figures out the essence of what a 2 is, with mind-boggling accuracy.
Okay, but here's the real kicker. Classifying things, saying that's a cat, that's spam, that's a 2. That's amazing. But the truly incredible jump, the thing that brings us right up to today's AI, is when it goes beyond a simple label and starts to generate a human-like description of what it's seeing. Look at this. This is an actual result from Microsoft's Caption Bot. It was shown a simple photo of Harvard Square. And look what it said. It didn't just output the tags people, building. It saw the relationship between them, it understood the action, and it constructed a full coherent sentence to describe the entire scene. That's the culmination of everything we've been talking about. Which, of course, leaves us with one final, pretty profound thought. We started this journey with an AI trying to solve a simple maze, and we've ended up with an AI that can look at a scene and tell you a story about it. So as these systems get better and better, they force us to ask a really fundamental question. If a machine can learn, perceive, and describe the world, what does it even mean to be intelligent?